Hello everyone. In this video, I'll be going over Fourier series and to prove whether or not if f of x is odd, even, or neither, and what does that mean for your Fourier series when you look at your overall f of x, what you're solving for with a sub 0, a sub n, and b sub n. So I'm going to go ahead and show for this what you would do, and then I'll explain what you would do in each case, whether or not it'd be even, odd, or neither. So for this one, we have our function f of x equal to negative 2x from negative 3 to 3 with a period of 6. So if our period equals 6, this implies L equals 3. Right. So we gotta have that part, and now we need to prove whether or not it's odd, even, or neither. So in order to do that, you need to look at your three cases for odd, even. So if it's odd, then f of negative x will equal negative f of x. And if it's even, f of x would equal f of negative x. So we'll go ahead and do that for our f of x, which is f of x equal to negative 2x. So if we say f of negative x, that means we replace x with a negative x, which would equal 2x. Now we have to set this equal to negative f of x. So that would equal a negative 2x. So that would equal 2x. So it's odd. And just to show that it's not even, we'll go ahead and do that. So f of x would equal negative 2x. Oops. And this should equal f of negative x, which equals the what we had at the top, which is 2x. So it is not even. And since it's odd, I mean it's not neither. So we'll go ahead and go on with odd. So if it's odd, that means we're dealing with sine. So if we're dealing with Fourier sine series, so this implies Fourier sine series. Therefore, a sub 0 equals 0, a sub n equals 0, and b sub n will equal 2 over L from 0 to L, f of x sine n pi x over L. Right. So the reason why a sub 0 and a sub n are 0 is because it's a sine series, and it's sine series because our function is odd. All right. So now we're going to go ahead and solve for b sub n. So b sub n would equal 2 over 3, since earlier we solved that L equals to 3. Then we go from 0 to 3 of f of x being negative 2x, times sine of n pi, dx on here, n pi x over 3 dx. Then what we will do now is integrate. So, or we can simplify it further, but like you can get the coefficients on the outside, do whatever algebra you have to do in order to make this easiest for you. So if you notice, we don't have a matching u for our du, so that means that we have to use integration by parts. So I'm going to go ahead and write that out over here in blue. So our u is going to have to equal negative 2x, because that's the thing we can take the derivative of, that doesn't change, which implies our du is equal to negative 2 dx. Then our dv is sine pi x, rather than over 3. And our v, sorry, I forgot my dx here. And our v would be 3 over n pi cosine of n pi x over 3. Because if we take derivative of this, we should get this. And if you look at it, we should. Oh, actually, it makes it negative. Sorry, my bad. To negative for our v. So this implies that our integration for b sub n equals uv, which is negative 2x, times, and just not forget, we don't want to forget that 2/3. All right. So we have our 2/3 times everything. So that's negative 2x for our u, our v being negative 3 over pi, in pi, times cosine in pi x over 3. All right, make sure I got that. All right, and this would go from 0 to 3. Minus the integral from 0 to 3 of u dv. Sorry, no, v du. Sorry, uv minus v du. So minus 3 over n pi cosine of n pi x over 3 times our du, which is negative 2x. Sorry, negative 2 dx. Right. So then this would equal, let's see here. I was going to simplify it down a little more, just make it easier. So then this would equal negative 4x over n pi cosine of n pi x over 3 from 0 to 3 plus the integral of 3n pi from 0 to 3. Oh, I forgot my 2 here. So it's still a minus. Cosine n pi x over 3 dx. All right. So now I'm going to go ahead and evaluate the first term and integrate the second term. So that should be negative 4 over n pi times 3 cosine of n pi 3 over 3. So I was going to write it as n pi. And we can do minus 0, but I know that term's going to be 0, so just have an x on the outside, so it'd be 0 times the cosine. So we're going to go ahead and just leave it as 0. Now I'm going to go ahead and integrate this next term. So it should be, so I have to divide by, so it should be 18 over n squared pi squared sine of n pi x over 3. Whoops, bracketing the wrong part. And I'm going to leave that as a coefficient on the outside. The 18 over n squared pi squared. This would be valued from 0 to 3. All right. So then this would equal, oops, up to the top. And this would equal negative 12 over n pi cosine of n pi, which you can rewrite as negative 1 to the n. Then minus, so this term is going to be 18 over n squared pi squared, but it's going to be sine of n pi minus sine of 0. Whoops, I'm not sure how the soup got in there. So this term will go to 0 because the sine of pi with any coefficient, any integer coefficient will be 0 because sine of pi is 0, sine of 2 pi is 0, sine of 3 pi is 0, and sine of 0 is 0. So this in turn goes to 0 as well. So it just equals negative 12 over n pi negative 1 to the n. So now we have our b sub n. We can plug this straight in to our f of x. So f of x equals a sub 0 over 2 plus your summation from k equals 1 to infinity a sub k cosine n pi x over L plus b sub k sine n pi x over L. But in this case, since our a sub 0 and a sub k were 0, we can say that's 0 and say this term's 0. So we only care about this b sub k term. So it'd really equal summation for k equals 1 to infinity. B sub k, which is negative 12 over n pi times negative 1 to the n sine of n pi x over 3. And if you want, you can label your region, which is negative 3 x to 3. So this is the overall answer. All right, so what we would do if it were to be even, which negative 2x would never be considered even. But if we got it to be even, if even, then that means that would imply a Fourier cosine series, which implies a sub 0 to equal 2 over L from 0 to L f of x dx. You can still evaluate from one. You can still do 1 over L from negative L to L, but this creates less work for you to do. A sub n would be in the same case 2 over L from 0 to L f of x cosine n pi x over L dx. And b sub n would be the 0 term, since cosine is this is a Fourier cosine series, and b sub n uses sine. When you integrate, you'll end up getting 0. So, all right. There's pretty much like the two cases you'll get, or if you got neither, I'll say in case if you did get neither. Then that just implies a regular Fourier series where a sub 0, a sub n, and b sub n would be all of these terms right here. Right here, the purple, blue, and green equations. Those would be your 3 terms that you'd use if neither. But I doubt they'll give you neither on the test, just because if you do have to do all 3, it's a live integration, and if there's an integration by parts, it'd be way more than 1 page that you would need. So definitely keep that in mind, that you probably will not get a neither. If you have anything that pops up as neither, it would be like a really short question. That just asks, tell me whether or not this is odd, even, or neither, and that would be all that they would ask. They wouldn't care. They wouldn't care about finding the rest of the Fourier series. They would, or else they might ask you like really simple, like it would just be numbers. It wouldn't have any like x's in it. But again, I really doubt they'll give you a neither and ask you to find the Fourier series. All right. Well, hope this helps. If you have any questions, please comment below. Good luck for your test.